All right, I just wanted to answer a few questions that were coming up in the discussion board for this week. So the first thing that I noticed is that there was a few questions talking about the domain and the range of a function. And so there's a few different ways that you can be given a function. You can be given the function graphed already. So if I gave you this picture, I'll put a little bit of labeling on it. Let's say these are counting by ones. And so if I have this function that starts here and then goes off, this should look familiar, kind of looks like the square root function. But if I have this function right here, when I'm asked to find the domain, remember the domain is the set of all the x's, and the range is the set of all the y's. And so if I look at my coordinate plane, we have our x-axis and our y-axis. And so for the domain, looking at it graphically, we really are just looking how far left and right does this graph go. So if I'm looking at it here, the farthest left it goes is -2, and then if I try and draw something on the right, it's going to go straight through it, so it actually goes forever to the right. So when I think about my axes here, I have -infinity to infinity for the x-axis, -infinity to infinity for the y-axis. And so in terms of left and right, the furthest left I go is -2, and the furthest right I would go would be infinity. So for my domain, it's all those numbers because there's an infinite number of points on this graph. So there's an infinite number of x values. So I would be using interval notation. And I will include -2 so it gets a bracket. And infinity doesn't ever actually touch. It keeps going and going and going, so it gets a parenthesis. So again, a reminder about those, that a bracket is used when you include the value. So it's like a filled in circle, or sometimes if you're in terms of inequalities, you'll see less than or equal to or greater than or equal to. So these are all when you include the value. And so if you don't want to include the value, then we use parentheses, open circles, and strictly less than and greater than symbols. So that's kind of the difference between those two. Now, the other way that you can be given a function besides graphically is by being given a set of numbers. So this was our first example graphically. Another way is going to be given a set of numbers. So if they give you something with these little curly braces, these curly braces are just saying here's this set, which is just a collection of some stuff. And so if it had some ordered pairs in it, and I'm just making something up right now, and these are ordered pairs. They have an x and a y, and they're inside parentheses. So here's one ordered pair, here's another ordered pair, here's another ordered pair. They separate those elements with commas. So when I say it's a collection of stuff, it's a collection of elements, and they separate them with commas. And so if I ask you the same question, what's the domain? This time there are only 3 points. I mean, you could turn it into a graph if you want, but really there's only 3 points, and so there's 3 x values. So the domain would include the numbers 3, 5, and 4. I separated them with commas, and you need to include the curly braces. Now within ALEKS, it'll say something about state the domain using set notation. So set notation means you need to start your collection of stuff with that little curly brace and end it with the curly brace, and you need to have commas going on in there compared to the interval notation. Now looking back a second, I realized I did not do the range on the graph of the one up above. So if I go back to this problem here, and I want to talk about the range, that is again all of the y values. So we're seeing how low the graph goes, which it kind of has this stopping point here, which would be at -1. And again, there's like thinking about like a ceiling or something. The graph's going to keep growing and growing and growing. It's always going to pass that. So it'll be going up to infinity. So the lowest it goes is -1. It does touch there, so I'm putting the bracket all the way to infinity. So domain, I'm looking at it left to right, kind of thinking about the walls. The range, I'm thinking about it like a floor to a ceiling, bottom up, to get my graph, or to get that range. So going to this set that I have for its range, I'm going to be looking at the y values. So I have 2, 7, and then another 7. I don't need to write 7 twice. So again, curly brace notation because it's just a collection of some stuff. I'm going to have the number 2, comma, the number 7. And again, it's written in set notation. Let's see. Another way that we might be given a function is by an actual equation. So the other example that we've seen is something like f of x equals 1 over x. So you can think about the graph because this happens to be one of our parent functions, but when I'm asking you for the domain for this function in particular, what you might notice is that we have a fraction. Anytime that we have a fraction, there's normally a problem with the domain. So if you look back at all your parent functions, all of them had a domain of all real numbers, which we would normally write negative infinity to infinity, except for the ones with fractions and also the square root, because we encounter problems if we use all real numbers as our inputs, as our x's. So the reason why we can't say this here is because we cannot have an x value of 0. You can't take 1 over 0. 1 divided by 0 is undefined. It doesn't make any sense. And so x cannot be 0. But it can be any number except for 0. So we could say any real number except for 0. Or in interval notation, that will look like, we get a picture on a number line really quick first. So we're saying we don't want to be 0, so it's like open circle here, but everything to the left and everything to the right, that's going from negative infinity to infinity. So we'll have negative infinity to 0, parentheses always on infinity. 0 gets a parentheses because we don't want to be 0, because then we're undefined. But then it restarts. There's 2 little segments there, 0 to positive infinity. So that would be the domain for that function. So again, the only time we have problems is if you have a fraction or a square root. So another example that a classmate had was if you have like f of x equals x plus 1 over like x minus 7 or something like that. And so again, for a fraction, we don't want 0 in the denominator. And so x minus 7 is equal to 0. Let's add 7, when x equals 7. So this would be a bad x. And some of you guys can just look at that and say, oh, well, 7 would make it 0 on the bottom. So we wouldn't want that. So it's going to look similar to what we just saw with our interval notation, but it'll be negative infinity to 7 union 7 to infinity. So there's like a little hole at 7. We don't want to include that number. Now, the other time that I said that you might have a problem with your domain is with square roots. And so again, if you're given a function like just square root x, that's one of our parent functions. So again, you can imagine the graph, but the other thing that we want to know or make sure of is that this number inside here cannot be negative, because what does it mean to have square root of like negative 25? Like we don't know that yet. It actually creates a whole nother number system called imaginary and complex numbers. So we don't want anything negative. So this number inside here, whatever it is, has to be greater than 0. It could also equal 0. So it could be greater than or equal to 0. And so what that would look like, and you could draw a number line if you want, is that we have 0 here. We do want to include 0 and everything bigger. So again, negative infinity, infinity. That would be including 0 to infinity. Now, if we change that inside just a bit, and we're going to work a lot more on these functions next week, if we have something like the square root of x minus 3, now we're thinking about, well, when is x minus 3 greater than or equal to 0? Well, it's greater than or equal to 0 as long as x is bigger than or equal to 3. So again, on my number line, if I put 3, I want to actually touch at 3. That would be a bracket, and then be everything bigger. Infinity to infinity. So we would say, oh, well, that will happen from 3 to infinity. Again, I have the closed bracket because I want to include that value. So hope that helps a little bit, kind of clearing up what domain and range is, and then also the difference between using set notation, which is the curly braces, and interval notation, which uses the parentheses and brackets.